Hello, everyone. Welcome to the portal. It's been a blast, a couple of days, online, virtual, everything is going smooth, and I'm really grateful for this opportunity to be able to present for you on the really topic that I'm really interested on, which is using AI in JavaScript to do crazy stuff like flying a drone. Now, before I start, I'd like to pay my respects to elderly from present, past, and future. And I also would like to uh, acknowledge the land, the custodians of the land on which we stand today. Now, today's agenda is very, very simple. We're going to go through a bit of overview of what's happening in terms of uh, machine learning with JavaScript in the browser side. Then we will have a look at the what, why people actually are interested in doing that. Then we'll have a short interview of the how. We're not going to go deep into the code and code examples, but we will have a few demos that I'm hoping to get you interested. My name is Yaser, aka Yas. I'm a lead front-end engineer at Tensorflow here at Melbourne, Australia. You can find me at Yas Hints, and I've got yashints.dev as my personal blog and website. You could find more information there. Machine learning is not really complex when you look at it like this. You have a series of inputs, you have a series of errors, the data gets translated into a series of mathematical information and goes through some mathematical operations. And then at the end of you get a prediction of, for example, is this a picture, a dog, or a cat? Now, today, I will not go through what are these layers are called or how the operations are done. Those are basically to the experts. I'm not an expert in AI or machine learning. I'm a web developer, and I'm really excited that we can bring this machine learning and all of this goodness into and into our day-to-day apps and leverage the power of machine learning to make the user experience a lot better. So first of all, let's see why we should do it in the browser. First, we definitely for sure, we have a wide distribution. Imagine if you have a Keras model or if you have a basically different type of model written in piece of Python code or however else that you're doing your machine learning, distributing that, it's going to be a painful uh, task at the moment. You need to publish it on one of those websites and get people to go and download all of that, including your data and also your done pre-training, your weight files, your models, and everything else, and then run them locally. Or you could use, for example, cloud services like Google Colab to allow them to try your model. But that's not a really elegant, and it's not that wide distributed throughout the world. Web is already everywhere. It's on mobile devices, it's on desktops. Everybody uses internet somehow, and they have at least access to a web browser. And that's why doing this in web browser makes a lot more sense because you give millions of people opportunity to try things out. Second, it's interactive. What do we mean by interactive? It means that when user is playing around with all of these features and all of these machine learning algorithms, they can interact with the machine learning algorithm. They can change the parameters on the fly. They can train the model on the fly in the browser. They can basically feed different data types um, into the model and so on. So it's a really great opportunity to give people the benefit of interacting with our machine learning algorithms. The next thing is sensors. If people are using machine learning on their mobile devices, there are heaps of sensors like light sensors, video, camera, uh, basically audio and a lot of different sensors that people could use to leverage and feed that data in machine learning algorithms. And the most beneficial is that data stays on the client side. What this means is really huge in terms of privacy. If you wanted to get one of your machine learning basically algorithms distributed at the moment, you need to export the data along with that so that people can retrain and add on top of that. But this isn't happening with in-browser machine learning because the data stays on the client and the privacy isn't in danger. And at the end, there will be no driver or installation required. So if you go back a bit, will Google started to basically create a TensorFlow, which is written mainly using Python. And in 2018, they created this playground. The URL is at the bottom. You can even now go ahead and try different things in there, change the parameters. But this is still a wrapper around the current model, which is running using Python. And they're using Colab to leverage and expose this interface through cloud. But this got a lot of attention. People could basically play around with different parameters and get different outputs, add layers, remove layers, and do a bunch of other stuff. This became a point of interest for many different people. And that's when they thought, if you could do it this way, why not do it in the browser? And that's when TensorFlow.js was born. TensorFlow.js is released in 2018. It has a GPU accelerated via WebGL capability. You could do inference training right within the browser, and it's fully open source. You can find more information about TensorFlow.js at github.com/tfjs. So what can you do with TensorFlow.js? You could author models from scratch inside the browser. This is really huge. If you have previously created a model, you would know that having the ability to access the APIs to be able to create the models from scratch is really beneficial because people could basically spin up a new application and start writing some JavaScript code to create their models and train them. You could also import pre-trained models. If you already have a pre-trained model and that model is exported, you could import it. And that's exactly how Google currently is distributing their current models using Google Cloud Storage. The other ability when we say import pre-trained model is that you can not only bring JavaScript model, which are stored in JSON format, but also you could convert and bring Python Keras models as well. So you could even get TensorFlow models imported into your JavaScript app and then use those. You could retrain one of those models, aka transfer learning, where you want to add something on top of basically something that someone has done, which is the subject of one of the demos we will go through to fly our drone tonight. So where can you currently run TensorFlow.js? You could run in all the major browsers. You could also run it on a mobile device. They've recently added WeChat integration. So a lot of different applications on WeChat are currently using TensorFlow.js. They added the ability for React Native developers to bring TensorFlow.js into their apps and use that. You could also use it on server side, on Node.js application. And the benefit of having the application written in Node.js is that you can leverage CPU. You also have a really good graphic card. You could basically use GPU to perform the operations and make the model run really faster, especially when you're And you could also run it in Electron apps, on a desktop platform. So you can see that they focus on not the browsers, but also a lot of different areas that are beneficial for the end user. So how does the TensorFlow work? At the core of itself, it's got a core API. The core API is basically the layer which talks to the low-level APIs, which are written in C++. Now, when you bring the model, you're not really using the core APIs. The core API is only used when you're creating a model from scratch. Then there is the layers API. The layers API allows you to create the models from scratch. You could add layers, you could add different parameters, you could add other improvements, and you could play around with a lot of different factors with via the layers API. And then on top of that, you have your model. So when you're finished with the layers API and your training, you already have a completed model. Now you could run this in the browser using WebGL. One of the goodness that they added recently is that you could also run that through TPU. So not only on CPU and GPU, but you also could use TPU on the Node.js side. And another point is that you could run it in the browser, but using a WebAssembly backend, which is really awesome because you could potentially run a lot of mathematical operations using WebAssembly is much faster. So you could run Python code or Rust code inside the browser. Now, if we want to compare our current model, basically the layers API is equivalent to Keras models. So when you have a Keras model, it will get translated into layers API. Or if you have a TensorFlow safe model, it will then get translated into our core API. Now, what are the benefits from the client-side perspective? We mentioned a few of these before. There would be no driver or installation. You would have access to sensor data, which is a really great opportunity to basically train your model as you go. So instead of having supervised learning, you could have unsupervised learning using sensor data. Data privacy is really important in terms of machine learning and what data is gathered from the user. And it's really a huge factor for all the companies who are interested in bringing Tensorflow.js into their current apps, because that gives them full control over where data sits. There will be no latency. So if we wanted to basically run something in the browser, send a command to a server, run, for example, inference on the server, and then return the result back to the browser, we don't have that anymore with TensorFlow.js. It's right there in the browser. Everything happens right where the user is, and everything is basically is really performing in terms of the speed. It's WebGL accelerated, so it's using the WebGL to perform a lot of mathematical operations to give more speed to basically inference and also training. And it actually reduces a lot of site costs. So you don't have to host your models, you don't have to run a lot of operations. And basically, if you're using cloud, it allows you to reduce a lot of computing costs. Because if, for example, you had 1,000 users using your application, which was running on the server side, 1,000 inference on server side will mean that you have to pay for that much computation. Whereas now it's running on the user's machine and you don't have to pay anything. So it helps you reduce server-side costs a lot. But what are the benefits from the server side? On the server side, you can bring machine learning into your Node.js stack. So if you have an application which is written in Node.js, you could easily bring the machine learning into that, and you don't need to, for example, interact with low-level APIs like C++ or Python. You could use existing models directly. So it gives you an interface which you can then use to run the TensorFlow models instead of converting them directly into your app. And also it uses CPU, GPU, and TPU, which was added recently to add the benefit of speed and computational power to the apps. So the more important part of bringing TensorFlow.js to world is the use case. As we mentioned before, there are a lot of use cases for this particular stack. If you look at the client side, you'll see people are using that in AR-powered apps. They're using to create gesture-based interactions with the user. They're using speech recognition. They're using accessibility to improve the accessibility of basically apps. You could use it in IoT devices to perform some analysis or do inference on basically different type of data which are coming from sensors. You could do sentiment analysis. You could do conversational AI, content authoring, and a lot of different things that are out there people are using, which basically I couldn't fit into one slide, but these are the most important ones to my opinion. Now, as we mentioned before, one of the benefits of bringing this into browser is that it gives people ability to play out with stuff and create innovative solutions on top of these awesome stack. On the server side, you could do basically machine learning pipelines. You could do on-prem and cloud computation to do training and inference as well. Now, there are a lot of pre-trained models already submitted into TensorFlow.js repository. Some of those are basically similar to, they are coming in different categories. So in terms of object detection, there's MobileNet, where you do, you know, detect an image or object inside an image, or you could do image classification and whatnot. In terms of human pose detection, there is PoseNet model, where you could basically detect what the pose of a person is based on their camera feed or a picture. There is BodyPix, which uses to segment human parts or human body parts. And there is a speech recognition, which basically helps you to create applications which uses voice recognition to perform some operations, which is the one we are using tonight for our demo. So one of the other that I mentioned was you could convert the current saved models even from TensorFlow.js, from TensorFlow Hub or a cross model, and bring it into your JavaScript app. And this is the flow. Basically, you run your TensorFlow pip converter on top of a saved model. It gives you a graph model, layers model, and then you use TensorFlow.js library on top of that to bring that model into a JavaScript app and use it. Now, it's really easy to get started. So in this slide, we're going to go through BodyPix, which is used for body segmentation. It's really easy to get started, and I just want to show you how easy is that to get one of the applications up and running in no time. So first thing you need to do is bringing the TensorFlow.js library from basically a CDN, or you could install it using npm. Once you've done that, you need to bring a preferred model. In this case, we are bringing BodyPix. Then we're going to have to define an image on our HTML side. Once that's done, we're going to give that image a source, which in this case is basically one of the pictures of my daughter, Ronica. You will load the model, get an instance of that model and load it. That will basically mean that it will bring the model JSON and the weight files loaded into the browser. And that's an asynchronous operation, so you're going to have to use async await or promises. Once that's done, you would then a method which is called estimate person segmentation. And that method runs the inference on top of this image, converts the image into data and runs the mathematical operations and gives you a JSON object like that. It basically gives you a height and width for your image and a data, an array, uint byte array of your data, which then you can for example, masking or segmentation. So in this instance, you could basically use the helper method of draw mask, and that will draw a mask. It's detected that the body basically is sitting at the moment. There are other models which are submitted, and the use cases are pretty huge. Like one of these models, which is called Creativity, is basically using, in this instance, I'm using my nose to play music. So imagine someone who has disability and they can play music with their hands. They could now have the option to play the music using Tensorflow.js inside the browser, because it's really easy to detect, for example, where am I moving my head, and then play different types of notes based on where my nose is positioned on the screen. You could use the link at the bottom to basically go and check this model and also a lot of different models which are submitted on that Google page. There are many major companies who are also using TensorFlow.js to improve experience. One of these companies is Airbnb. Airbnb is using this, using TensorFlow.js in a few different areas. One of those are detecting that if you are uploading, for example, your photo or your avatar into Airbnb, Airbnb will use TensorFlow.js to detect whether this is a type of an ID where you're uploading instead of your purely your, and that will basically pop up a warning for you that, are you sure you want to do this? You want to use this photo? It seems like this has some confidential information that don't want to be publicly available. This only works currently in US. They haven't adapted in different countries, but that's basically is a really great use of machine learning inside browser. One of the other thing is they are trying to detect, for example, the type of rooms based on the photos that are uploaded. So when you upload a new photo, they will use machine learning to detect what type of room is that, and then suggest, hey, is this a bedroom or is this a kitchen or whatnot? And the other, one of the other areas where they're using Node.js is to detect objects inside a photo. So in the top left corner, in the bottom left corner, you'll see that, for example, it has detected that there is a desk with some chairs in there, there's a door, there's a window, and so on. So it helps you to basically list all of your furniture really easy. And this is a really good experience for end user because it happens automatically. They don't know what technology is used on the scene. All they care about is how easy is their job. And this is a really great experience. So at this point, I would like to do a quick demo using speech command. So because it's really easy to perform machine learning in the browser, what I would like to do is I will bring my console here, and then I will do yarn watch, and that will bring up my demo. What I've done here is that the default speech command has a few words, to be exact, 18 words that it could detect at the moment. And what I've done is that I've created a little application where I will say a word, for example, left, right, up, down, and then it will bring a sort of emoji which is associated with that word. So let me just make sure that the model is loaded through our network and everything is happening. Yep. So it seems like everything is happening. So let's give it a shot. This might not work because we might be using the same mic, but we'll try. I haven't actually tried this before using while I was broadcasting. So let's see. Up, up, down, down, left, right, crap. Holy crap. Yeah. Okay. So it is 100% accurate, but you get the idea. And this is a really small application, which is basically used in a little silly demo. But the benefit of having this sort of interaction is really huge. Just switch. Okay. So there are people in the community who are doing great stuff using Tensorflow.js. Asim Hussain, who is a developer advocate for Microsoft, has created AIJS.rocks, a website which has heaps of different models are created basically by community, by people who love to contribute to open source. And these are basically exhibited on that. And you could go and play with most of those models. Some of those are, not all of those are open source. So you could play with some of those were open source, and you could touch with people who have put their models in there, but they're not completely open source. Like the authors who wanted to basically they created a service and they wanted to use that service to make some money. But it could be a win-win situation, even if you have to pay a small fee. Now, at this point, let's go and do our actual demo. So in this demo, what we're trying to do is, I've got this application here, which has a backend part, which is basically, I've got a code is borrowed from VestBoss, who is a great developer and who's got a lot of different open source projects. This one is one where he tries to use a socket to control a drone, and the drone is a DJI Tello. If I could my browser to show you the actual drone, DJI Tello, which has got a JavaScript SDK. JavaScript SDK that should bring the drone somewhere. This one. This is the drone which we'll be using tonight. This comes with a JavaScript SDK, and you can connect through Wi-Fi and send voice commands, or basically send commands through socket to that and control the drone. And that's what we're trying to do. We're using speech command. We're gonna train our model. So in this instance, I've created this front end, which basically is, if you run this front end now, I could basically come into, let me just make it bigger. Okay, too much. Okay, cool. So let's go into speech command and do your watch. So this will bring up our demo. Unfortunately, I could not use real time. This is the app. All it does is that I've put some buttons in here to sample basically words and capture them as part of the audio capture, and use those to train or retrain our speech model, which is called transfer learning. So I'm just reusing the speech model. I'm trying to teach the speech model new words. Technically, that's what's happening here. So I've used basically take off, land, and flip. And these three words, we're going to use those to send those commands into our drone and control it. And then what we need also in order to bring the accuracy up is some background noise. So at this point in time, I'm not going to run this app as a live demo. What I've done to prevent any hiccups, because I needed to disconnect from internet and connect to my drone, I'm going to run this app here. All right. and we'll watch this together.
Hope you've enjoyed the talk so far. In this moment, we're going to have this demo of me playing around with speech command model from Tensorflow.js GitHub repository. I'm going to customize this model. I've written the code before to customize this based on a few words. So what you have to do here now is we're going to use 3 words, which is takeoff, land, and flip. And then we add some background noise in there just to make sure that the training goes as planned. And we use that to fly up the drone. The drone is a DJI Tello. It comes with a JavaScript SDK, and you can send commands to it using Socket.io. And that's basically over Wi-Fi. So what I have to do here is I'm going to train this, and then I'm going to switch my Wi-Fi to connect to the drone, and we use that to fly the drone. All right, hope you're ready. So start by training the model. So what I have here, I've loaded the model. This model is hosted free on Google Cloud storage. So when you include the model, it's going to bring the model and the weight file directly into the browser. The rest just happens in the browser. Now let's start by the training. So I'm going to start by the first word, which is takeoff. We roughly needs about 250 maybe samples minimum, just so we get it working. So let's do that. Ready? Takeoff, 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 takeoff. So the reason why this is lacking behind is that I've got recording running in the background. Well, we should have around, yeah, sounds about right. So we have 272 samples for now for takeoff. So let's do one, which is land. We need about roughly the same size of samples. So let's do that. Next. Land, 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 land. Okay. So I'm going to have to wait for this to finish because it's using, again, it's lagging behind. So it seems about right. Now we have to basically do the flip.
Borders of your elements in your page. And it's really cool. Sometimes you may have like a designer can send you, okay, we need all of these to be on top here and here and here. And then mobile, I want this one to fly to the moon, and I want this one to go scuba diving, and I want this one to just die. You're like,
do now,
do that.
Bring up a drone's noise. So let's go to YouTube, and I'm going to bring up a drone flying sound. Now, the reason why we need that is when we train, we need some background noise. By the time we send the first command to drone and the drone is taking off, the drone itself has a lot of noise. So when we send the second command, the model isn't able to figure out what you're talking about here. So it doesn't detect any sound. So what we need to do is basically play some drones noise here. Let me just bring volume a bit. And I'm going to do that to record some noise. Okay, so should be enough. That was basically the background noise we needed to let the model filter out any background noise which is coming through to the microphone. So now what we have to do is train the model. So we just run the training. The training happens right here in the browser. I'm just running it on basically on 10 epochs. We see how we roughly get to
accuracy, if we get about maybe 70%, we're in a good position. So let's see. So we reached about 36%, 63%, which is not bad, not ideal. But at this point, we're going to have to basically run the commands and see how we are the drone. Okay, so I'm going to send a command. So what we have here is, I'm going to show you here. I've got the server running in the background. This is the background service which is running and sends the command from our front end to the drone. And once that's happening, then we'll be able to fly the drone using the commands we'll send. So just a moment, I'm going to set up the drone because the drone is not connected. I'm going to switch my Wi-Fi as well. So just a second. Okay, so I think we should be ready. If I send a restart command here, this is now connected to my drone, and I can come here, and basically this is okay. So we send the first command now. Ready? Here we go. Take off. Take off. Flip. Land. All right, seems like it was a success. Okay, so how good was that? Let me just again swap these two. Cool. So for some references, you could use TensorFlow GitHub repository. There is a really good full course on Free Code Camp. I've got a blog about it with how to get with TensorFlow.js. You could find the slides on the last link. And there's also colabs.develop.google.com, which has a lot of good examples of different TensorFlow.js demos and models throughout, basically using different pre-trained models that they could just use. Now, with the TensorFlow.js, possibilities are endless. Let's bring the fun stuff to the web. The web doesn't need to always be boring about CSS, box models and styling. This was said by me, which is someone famous. Hope you've enjoyed this talk, and thanks. Any questions? I'm not sure how much time we have. Hit me up here, or I'll be around in the basically the booth, the info booth, and also other different places on Slack that you could reach out to me or directly. Thank you so much. Jacob, do we have time to get questions here?
What kind of applications do you see for AI-controlled drones?
Sorry, what was the question?
What kind of applications do you see for AI-controlled drones in the future?
So basically, what we're talking about here is a really small app that I've written for fun. But imagine that you wanted to control the drone with more accuracy than a controller, or where you don't have basically access, and you wanted to control it in a remote area from distance. So you don't necessarily are on site to fly the drone. The drone is somewhere else, and you just control it remotely. This is a really great example to be able to do that. But not only in terms of work commands. Imagine that you could basically use the camera feed from drone to detect objects, for example, and run inference and, for example, raise an alert if the drone sees, for example, someone stuck somewhere in an accident, or basically in somewhere in fire, where firefighters are basically using the drone to figure out if someone needs help, or those sort of scenarios are really great in terms of getting image recognition into drone or other type of command. Like this voice command was really easy for me to set up, so I just used that. But the next steps will be probably get the camera feed and then run the camera feed through a model and then use inference on top of that. Could also be used, for example, on detecting congestions on the streets or accidents or different type of things that could be really helpful. Any other question?